Good morning, my dear students. In today's class, I will be discussing about the circles class 9. A circle is the collection of all points in a plane which are equidistant from a fixed point in the plane. Let me explain about this. As I already mentioned, a circle is the collection of all points in a same plane which are equidistant from a fixed point in the plane. Let me consider this circle. We have got two types of points. The center point is called fixed point, and that is also known as focus. And there are so many points like A, B, C, D, E, F, G, H, etc. We can have n number of points on a circle, and all these points lie on the same plane of the paper. Is it not? Paper is the plane. Let me consider. This is the x-axis and this is the y-axis. So now this circle lies on xy plane. Do you understand this? And all these points lie on the same plane, that is xy plane. The z-axis will be above the plane of the paper. So let us not worry about this. We are talking about only xy. And what about these points lying on the circle? They are called locus. Okay, and the plural is loci. So it means that is, these are all the moving points on a circle. In fact, this fixed point and moving point, let us connect. This is the center point, fixed point O and A, OB, OC, OD, OE, OF, OG, OH, all are of equal distance. It means OA is equal to OB, OB is equal to OC, likewise OD, etc. Okay, so this is the fundamental point you should understand. And all these equal distances, they are called radius, plural radii. Okay, so OA is equal to radius, it can be represented as R. So OA is equal to R, OB is equal to R, OC is equal to R, etc. Okay, so we have now some idea about the circle. Now let us move to the next point. Equal chords of a circle. Equal chords of a circle are of congruent circles subtend equal angles at the center. Remember, equal chords of a circle are of congruent circle subtend equal angles at the center. What do you mean by this? Let me explain. First of all, you should understand what chord is. A chord, let me draw a circle. So this is the center of the circle. Now we have a chord AB. This is O, center of the circle is O. And I am drawing another chord which is of same length. So actually this is called chord. So chord is the line segment that connects the 2 points on the circle. So we have to take the identical chords. For example, if it is a 3 centimeter means I have to select another chord of the same length 3 centimeter. So this is CD. Okay. So these are called equal chords. Are you able to follow? So these two are equal chords. And what do you mean by congruent circle? Let me draw 2 circles. So the 2 circles have same radius. Okay. O, O dash. Let me draw the same AB. And I have another chord on the another circle CD. So both of them are equal because these two are congruent circles. Are you able to follow? Congruent circles. Clear? Now let us have this. Equal chords of a circle. Equal chords of a same circle or different circle but they are congruent. Congruent means their radius or their radii are equal. So exactly same circles. They are called congruent circles. So equal chords, they subtend equal angle at the center. At the center means this is the center. So it has an angle like this. So AOB is an angle. So this is chord 1. Let me have the chord 2. Okay, chord 2. For which the angle subtended with the center. Okay. So this is COD. COD. That's all. Do you understand this? So equal chords of a circle or congruent circle. These are congruent circle. In this case, you can have AOB. What is this? COD. So let us mark this angles. So this is AOB, COD. So if they are two equal chords of same length of congruent circles or the same circle, then their angles subtended with the center will be equal. Are you able to follow? So equal chords of a circle subtend equal length, equal angle at the center. This is the second point. Do you understand? Now let us move to the third point. If the angles are subtended by 2 chords, please note down. This is the second theorem. Now let us move to the third aspect. If the angles are subtended by 2 chords, if the angles subtended by 2 chords of a circle or of congruent circles. Okay, of congruent circles at the center. At the centers. Centers means a corresponding centers. You can mention corresponding centers. Okay, or equal. the chords are equal. What is that? The chords are equal. What do you mean by that? Angles are subtended. In the previous case, equal chords means equal angle. So this is the way you can simply remember. What is that? Chord 1, chord 2 are equal. So angles, center angles, you can put angle, center angles. CA1 is equal to CA2. That's all. This is the way you can easily remember. Let me repeat the previous theorem. In this case, this is the input, that is the chord length, you can put CL. Chord length 1 is equal to chord length 2, that is AB is equal to CD. This is the chord length. Then chord angles, so in this case AOB is equal to COD. Now in the next theorem, it is the converse of this second theorem. That is, if chord angles are equal, okay, if chord angles are equal, then chord lengths should be equal. That's all. So this is the converse of the second theorem. What do you mean by this? If the angles are equal, what are the angles? AOB is equal to COD. In that case, if then AB, chord length AB is equal to chord length CD. So this is applicable for a single circle having two chords of same length or same angles, or it is also applicable for two different circles but they should be congruent, so their corresponding angles, that is with the center, are equal, means their corresponding chord lengths should be equal. Do you understand this? Okay, please note down. So this is regarding the third point of the circle. Okay, now let us go ahead with the next theorem. The perpendicular from the center, fourth theorem. The perpendicular from the center, of a circle to a chord, of a circle to a chord, bisects the chord, bisects the chord. So what do you mean by this? Let us draw a circle, the perpendicular from the center. So let us have this. So the perpendicular from the center, this is O. Let me draw a perpendicular line to a chord, the chord AB, and I have drawn OE. So this is perpendicular. Okay, so OE is perpendicular to AB. OE is perpendicular to the chord AB. If it is the case, it means it meets at F. Okay, so you can also mention as OF is perpendicular to AB. So this is the input. What could be the output? Okay, let me say this is in, this is input, this is output. So if OE is perpendicular to AB, that is OF is perpendicular to AB. Where is OE? OE is here. Okay, it is perpendicular, and we can also mention this OF. If it is the case, then AF, okay, is equal to BF. variable follow, that is AF is equal to BF. It means AF is the midpoint of, F is the midpoint of what? AB. So do you understand this? So F is the midpoint of AB. It means it equally, that is this OF divides equally the chord AB. Do you understand? Right, please note down. Now let us move to the next point. Fifth theorem. The line drawn through the center, the line drawn through the center, the line drawn through the center of a circle to bisect a chord, to bisect means divide equally, bisect a chord is perpendicular to the chord. So when you try to remember as a statement, it would be very difficult for you to remember. Best thing is you can adopt the algebraic method or some iconic representation or by some symbols. For instance, you know very well the line drawn through the center of a circle. So you can draw the circle, the same strategy, the same circle can be used. So OE, the line drawn through the circle to bisect the chord. So you have got already by AB. It bisects. Okay. So this bisects. So in this case, what is the input? This is the converse of the previous theorem once again. So whenever such type of theorems are available, you will be having some converse also, the opposite. You can interchanges. It means input becomes output, output becomes input. So what is the output here? F is the midpoint, that is that line is bisect. Okay, bisects the, that is bisects the chord. So here the condition is the line is bisects the chord. The line bisects the chord. If it is the case, it will be perpendicular. So the OE is the line or OF is the line. OF bisects the chord AB. It means OF is perpendicular to AB. That's all. So here what we have done, OF is perpendicular to AB, then it becomes, that is, it bisects the chord. AF is equal to BF. Okay. And in this case, when AF is equal to BF, right, that is AF is equal to BF means it bisects, is it not? So AF is equal to BF means OF is perpendicular to AB. Just you have to reverse this. Okay, do you understand? Right, let us move to the next one. Have you noted down? Right, let me move to the next concept. Sixth theorem. Here, there is only one, there is one and only, there is one and only one circle it means they are insisting, passing through, three non-collinear points. Okay, for example, let me have A, B, C. These are called non-collinear points. So based on this, we can draw only one circle. So you can connect all these circles so that it will form all these 3 points, so that it will form a circle like this. Okay. So you can form only one circle like this by connecting all these 3 points. So there is a separate practical geometry. I will give you a link so that you can go through that. Using a compass, we can easily draw a circle based on 3 non-collinear points. Are you able to understand? So what do you mean by this? If you have got the 3 non-collinear points, we can form one circle only. Okay, so there is one and only one circle passing through 3 non-collinear points. Do you understand? Right, we'll move to the 7th one. Equal chords of a circle are equidistant from the corresponding center. Take down. Equal chords of a circle. Equal chords of a circle, whether it is a single circle or of 2 circles, that is congruent circles, or of 2 or even many. So, but it should be congruent circles. See, whenever we give some theorem, it should be applicable in all terms. So, congruent circles are equidistant. Equidistant means that they should have equal distance. Equidistant from the center. Or from the corresponding centers. Okay, so what do you mean by this? For example, let me have a single circle like this, and I have a center. So equal chords means I have AB and CD. So I may be any number of chords, but they should be of equal length. So AB, CD, EF, they are all equal from the center. Okay, so let me have this A, B, C, D, E, F, G, and this is H, this is I. It means that is equal chords means what are the inputs? Input, output. Okay, now O, A, not OA, OH or OG. This is OG. Input, we are talking about equal chords. So AB, okay, is equal to CD. So these two are equal, and you can have a number of chords also. Let me have 2 chords here. So 2 equal chords, they have equal distance from the center, that is O. So OG is equal to OH. These two are equal. Are you able to follow? Okay. So you can remember this in a symbolic way also. So what are the key points here? Equal chords, equidistance, that's all. Right? Now let me move to the next point. And this is applicable in the case of two different circles, but they are of same parameters. That is, let me draw for the congruent circles. Congruent circles, you know very well, they have equal radius. So these are the two circles and their corresponding centers, O dash. Let me have AB and this is CD. Okay, so they are of equal length. So what is the input? AB is equal to chord length or same, and the corresponding centers, the distance will also be equal. So let me say that is OAB, means you can have G and H. So OG is equal to OH. Are you able to follow? What about this? This is equal chords. Equal chords means equal distance. So equidistant. Equidistance from where? From the corresponding center. Do you understand? Corresponding centers. Okay. Now this is for a same circle, but we had considered two different chords of same length and they have same distances from the center, and this is applicable for congruent circles. So you should know both, right? Next one. Let us move to the 8th point. This is a converse of 7th one. Here, chords equidistant. What is that? Chords equidistant from the center. From the center or the corresponding center in the case of congruent circle. So, of corresponding centers of a circle or of congruent circles. Congruent circles, okay, are equal. So what do you mean by this? This is nothing but the converse of the previous theorem. So in this case, this is the input and this is the output. You can interchange this. So input, output. Chords are equidistant, that is OG is equal to OH. They are equidistant. It means the corresponding chord length should also be equal. That is AB is equal to CD. That's all. Do you understand this? You can just interchange the input and outputs. Next one. Have you noted down? Now let me summarize whatever I have discussed so far. I'll let you know that is how to make a concept map or mind map for easy memory. So what is our first point? This is the first one. Circle it can be have n number of points, but all of them are lie in the same plane. So first point is we talked about locus and focus. So focus, locus of a circle, it is understood because we are talking about only circle, so let me not repeat the circle. Focus, locus lie on same plane. Okay, and the plural form is loci. Many points. And what is the second point? That is angles are subtended by two chords of a circle or of equal chords. So angle, center angle. Okay.
Sir, that's the theorem, sir. It's not.
No, that is, we can consider all these as points only. So the second point is because I am just summarizing all the concepts of the circle. So here, what is that? AB is equal to CD means, and angle should be equal. That is EF. So CA, center angle, you can have like this. Center angle CA 1 is equal to CA 2, that is chord length, chord length CL1 is equal to chord length CL2. Then the center angle should be equal. So this is the easy way you can understand. Third point. What is the third point? This is the converse. Okay, you can just interchange. That is CA1 is equal to CA2 means CL1 is equal to CL2. That's all. What is the CA1? Center angle. So the center angles are equal, chord lengths should be equal. This is the third concept. Fourth one, we talk about the perpendicular line, is it not? So here what we have put, OF is perpendicular, okay, to AB. What is this OF? That is the central line, that is a line segment that is drawn from center. So here OF. So OF is perpendicular to AB means they bisect. AF is equal to BF. Okay, so you have to remember this bisect and perpendicular. Okay, then fifth point, this is the converse of this theorem, previous theorem. So in this case AF is equal to BF means OF is perpendicular to AB. Do you understand? So this is the easy way you can remember all these theorems. Sixth one. What is the sixth one? There is only one circle possible through three non-collinear points. So here we talk about one circle through three non-collinear points. Okay, so don't forget this. Only one circle is possible through three non-collinear points. That is, non-collinear points is like this. Then 7. Equal chords of a circle, okay, are of equal length. It means equal chords of a circle. Equal chords means what? That is AB is equal to CD means OG, that is you can put OE also if you want. Otherwise OG is equal to OH. What do you mean by this? This is equal chords. Okay, and what about this? Equidistant from the center. Equidistant from the center. Okay, so you have to remember like this. So what about the 8th point? it is the converse. That is OG is equal to OH, means AB is equal to CD, equidistant chords, equal chords. Okay. Now let us move to the 9th point. So this is the summary of circles. Okay. Now let us proceed with the 9th point. If two arcs of a circle are congruent, if two arcs of a circle are congruent. Congruent means equal in all parameters. Congruent, their corresponding angles, chords are equal. Their corresponding chords are equal. Chords are equal. And conversely, if two chords of a circle are equal, then their corresponding arcs are congruent. Now in this case, let us have a circle. Two arcs of a circle means this is the center. I have an arc like this, AB arc, and I have another arc like this. They are of equal length. So arc are congruent. Okay. Two arcs of a circle are congruent means they are of equal length. CD, they are of equal length. Let me represent this by AB arc is equal to CD, arc CD. Then their corresponding chord lengths. This is the chord length. Okay. So AB is equal to CD. That's all. So this is arc. This is the chord length. We talk about the chord length. Is it clear? And you can converse this also as a 10th concept. What do you mean by that? If the chords are equal, they have equal arcs. That's all. You can simply make it as a converse of 9. What do you understand from this? This is the input. This is output. So if AB chord length is equal to CD, the arcs are equal. Okay. This is the easy way you can remember. Then 11th one. Congruent arcs of a circle subtend equal angles. Congruent arcs of a circle subtend equal angles at the center, because they have equal chord lengths, is it not? So equal angles, that is center angles are equal at the center. Okay. So what do you mean by this? The same is applicable. We draw a circle, we have, and this is the center point, O. Now we have two chords of same length, of same arc length, arc, and the center angle is this one. Okay, you have another center angle. Let me say AB arc, CD arc, the angle. Okay, so the angle is ABCD. Let me put EF. So arc input, this is output. Arc AB is equal to arc CD. In that case, angle AOB is equal to angle COD. That's all. Clear? Now let us move to the 12th point. The angle subtended by an arc. The angle subtended. The angle subtended, you can have this as 10A, 10B also, so that you can maintain the numbers. This is 9A, this is 9B. You can make it as 10 and this is 11. Now, the angle subtended by an arc. The angle subtended by an arc at the center. At the center. What is that? The angle subtended by an arc at the center is double the angle. Is double the angle. Is double the angle subtended at any point, subtended by it, subtended by it at any point on the remaining part of the circle. On the remaining, the statement is very important, part of the circle. Okay, so what do you mean by this? The angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. So you have the angle subtended by an arc. Okay, let me consider this is A, B. This is the center. The angle subtended by an arc at the center means O. That is AOB. Do you understand? AOB. Okay. Subtended by it on any point. So the angle subtended by an arc at the center of the circle is double the angle subtended by it on any point. Means any point can be here. Say AB, this can be C. Draw this. Okay. So this will be double. So let me say this is X and this is 2X. Do you understand? So AOB, angle AOB, that is this center angle, is equal to twice the ACB. Do you understand this? That is angle AOB, center angle is twice the angle developed at any point. ACB. If it is X, this will be 2X. Okay? Is it clear? Then, now let us move to the next theorem or next concept. These are all, because these are all the mix up of theorems and concepts. So let me go ahead as concepts. So this is the 11th one. 12th one. 12th point regarding the circle. Angles in the same segment or of a circle are equal. Angle in the same segment. Take down. Angles in the same segment. In the same segment. Okay. Angles in the same segment of a circle. Of a circle. Or equal. Or equal. What do you mean by this? First of all, you should know what segment is. Okay. What do you mean by segment? That is nothing but the area covered by a chord and the corresponding arc. Okay. And the angles subtended from this will be same. For example, you can have n number of angles like this. Okay. All are same. This is what they mean. Angle 1, angle 2, angle 3 means angle 1 is equal to angle 2 is equal to angle 3. And this is the segment. Okay. This area is the segment. Do you understand this? Okay. Right. And what is the third point? That is angle in a semicircle. Angle in a semicircle is a right angle. Is a right angle. What do you mean by this? Draw a circle. A chord passing through the center is called what? Diameter. Okay. Therefore, this is a semicircle. So, this part is a semicircle. This area is semicircle. So, the angle subtended by it, a semicircle means only this one, this portion. And let me draw, this will be 90 degree. You can draw, this is also 90 degree. So, you can have n number of angle, all of them will be 90 degree only. Do you understand this? Let me say this is A, B, C, D. What do you mean by this? Angle A, C, B is equal to 90 degree. Angle A, D, B is also 90 degree. So you can draw n number of angles, all will have 90 degree. So do you understand this concept? So this is the 13th one. Okay. Right. Let us proceed with the 14th one. If a line segment, joining two points, if a line segment joining 2 points subtends equal angles at two other points, lying on the same side of the line containing the line segment. The 4 points lie on the circle. The 4 points lie on the circle. Okay. So do you understand this concept? Can anyone draw this? If a line segment joining 2 points subtends equal angles at 2 other points lying on the same side of the line containing the line segment. The 4 points lie on the circles. So it means you have a circle, and if line segment joining 2 points, so 2 points subtends equal angle at 2 points. Equal angles at 2 points means this is a center angle. Okay, you have another 2 points, so A, B. So this is a line segment. Okay, it forms an angle, and this angle has another set connecting C2. So you will have this 4 points lie on the circle. All 4 points lie on the same circle only. Okay. Then 15th, this is the 15 and the 16, that's all. 15th point, let me discuss about the 15th concept. What is that? The sum of either of opposite angles. Sum of pair, either pair. The sum of either pair of opposite angles of a cyclic quadrilateral is 180 degree. What do you mean by this? You can draw a circle, and quadrilateral means what? Four-sided figure drawn on the circle. Let me say A, B, C, D. This is the center. So this is a cyclic quadrilateral. The sum of either pair. So let me say this is one pair, A, C. Another pair, that is B, D. Okay. So let me say this is angle A. Okay. Let me represent this by number also. Angle 1, angle 2, angle 3, angle 4. So angle 1 plus angle 2 is equal to 180 degree. Similarly, angle 3 plus angle 4 is 180 degree. Okay. So it means the sum of all these angles will result 360 degree. Is it not? Okay. Now you can have the converse of this one. Okay. If sum of pair of opposite angles of a quadrilateral is 180 degree. Okay. Then the quadrilateral is cyclic. That's all. Okay. So let me have a quadrilateral like this. This is a quadrilateral. Its opposite angles, the sum of opposite angles 1, 2, 3, 4 are equal. So 1 plus 2, okay, is equal to 180 degree. 3 plus 4 is equal to 180 degree. It means they are cyclic quadrilateral. Are you able to follow? Then they are cyclic quadrilateral. Clear? Okay. So you have to memorize all these 16 points in the circle. Okay.